Hello and good morning, everyone. I hope everyone's enjoyed your night so far. It's day 3 already. Welcome to our presentation, Creating Games Based on a TV Show. I'll start by introducing myself. My name is Maha Mehdi. I am a project manager at Tintash. So for those of you who haven't heard of Tintash, it is a Stanford alumni-led full-service development studio that has been working with stellar companies in the games, mobile, and web app space for the past decade. We are a 100+ strong team of artists, UI UX experts, engineers, QA professionals, and project managers. We initially started off as a gaming studio back in 2007. Worked with names like Slingo, Digital Chocolate, and Stick Sports. Since 2011, we've also successfully ventured into the mobile and web app space. Our expertise run across multiple verticals, including health tech, ed tech, IoT, and gamified apps. So speaking of team, I have with me Hira, Jamshed, who is the art director at Tintash and was the art lead on Beatbox, and Hamid, the lead developer, who has joined us remotely for this presentation from Lahore. I'll be shifting over to them momentarily to provide insights on art and engineering pipelines that were followed for Beatbox. So to give you guys a bit of an intro on Beatbox, this is an Australian-Canadian animated children's television series created by Josh Wakely and produced for Netflix by Grace, which is a storytelling company. They have 2 seasons up and running on Netflix, all episodes paying a tribute to Beatles songs and re-envisioning them for kids of our generation. So this show won an Emmy Award and became the inspiration for our app, Beatbox Sing-Along. And we wanted to make sure that the kids could take the best parts of the show with them while they're experiencing this app. So before I dive into the app any further, I'd like you all to take a look at the Beatbox trailer. Okay. So the app has a selection of episodes taken from the series itself, and it has been transformed, the scenes have been transformed into an interactive experience for kids. There are 2 main modes within the app, which is one, a play-along mode that encourages kids to interact using gesture-based interactions like tap, drag, tilt, or zoom. And the second mode is a sing-along karaoke mode, where you can record your voice as you sing along to a selected Beatles song. So, and like any usual game, a game made for a TV show has similar questions and requirements associated with it. The only difference is to streamline the complex feedback loop with the studio itself, and to make sure that the quality of the assets turns out as expected. Hira and Hamid will be walking you through some challenges we had later down the road while we were in production. So to give you an overview of the project, as a project manager, my role was to discuss and narrow down project requirements and figuring out the app scope. While we were doing this, we addressed the following questions. What should the art style be? Who is the target audience? Which platforms should we release on? Which engine to use? That was easy. We were using Unity all the way. Any software to use for the 3D models. What should be the size of the team? That was to be defined by the scope itself. And of course, what kind of development cycles should we follow? So we basically went ahead with a 3D perspective view, as you've seen in the trailer. The target audience is basically kids between the ages of 2 to 5. We have already released the app. It was initially meant for iOS and Android. We followed up with a build for Amazon. We used Unity because for reasons that we'll basically be touching upon later in the presentation as well. We used Maya for low polying the 3D models. And our team was small. We started with 5 people. So it was myself, Hira, Hamid, the lead engineer, and apart from that, we had 2 other artists. One was an animator and another concept artist. And we started off with defining the project and details in the pre-production stage, followed up with an excessive production stage, and then we moved on to an execution cycle. And the timeline for this entire project was 8 months, followed by 2 months of polishing. So I primarily contributed in the song design phase, which was distributed between scene setup and mapping character animations before it could go on to the animators. Apart from that, we had to create data entry for the songs themselves to make sure that they aligned with the lyrics you see on the screen. And apart from that, I just had to make sure that my team collaborated properly. While all the artists and the engineer and myself, we used Unity, we were collaborating via source tree to make sure we all had the same build and updates. So touching upon scene setup. Before we landed on this particular layout, this was first done in 2D. I basically sat with the artists and we used their high quality assets to create a layout that could help define the layout for the artists and the engineer before they could move the setup into Unity. This is how it turned out. These are all low poly assets that you see. This is Ticket to Ride, the second song. All these setups, they are a mix of 2D and 3D assets. We tried to create an illusion where we could save performance and give good quality assets as you see in the cartoon itself. And this is the fourth song. So I hope a lot of you would be aware of the Beatles songs and could catch on the names. And so in terms of mapping character animations, before an animator could start animating, I had to go through the process of picking out static frames that would define an entire animation. These are examples of a few charts we created per character. There were about 100 animations in the entire app. They were divided between individual and team animations. So yeah, we picked up a single frame and mapped an entire animation around it. So this was an iterative process with the animator, and we decided to get the feedback on the animations using this flow. Right, so moving to the song data entry. Sorry, excuse me. I used Google Sheets as a primary way to first listen to the song and then write out the timing for the song, and then it was converted into seconds that you see here. This was then moved into MonoDevelop, which was the IDE being used within Unity back in 2016. We basically copy pasted the entire data here after running it through a validation check. So the lyrics and the timing of the music track sank really well. Oops, sorry, is that hers? Okay, so I believe this is, so yeah, the data entry was a very crucial part of it. Getting that right took us a few cycles. We eventually got it right. It was one of the challenges I had in game design. I'd like to now move on to my fellow, my colleague, Hira, who would basically guide you through the art pipeline that was followed for Beatbox.
Awesome, thank you so much.
Over to you, Hira.
So I'm Hira. Jamshed joined Tintash right after graduated as a junior game artist and working as an art director now. My role in Beatbox was to manage the overall art pipeline, lighting, artifacts, art directions. And today I'll be talking about some of the challenges we encountered, which is the challenge in pre-production when we were studying the characters and issues we faced for game-ready assets, why we decided to use combination of 2D and 3D assets, an overview of hard surface animation in Unity, and scene lighting with 2D images, a little overview of particle effects, and why Unity is a center hub for the teams working together. So let's start with character study. We spent tons of time watching all the episodes to list down what personality each character had and how they're interacting with each other, studying their own screen presence. This practice gave us lots of insight on how to animate these characters and what body language belonged to which character. One of the challenges we faced was with Walter. He's a sluggish character with limited arm movement. Initially, we animated his arm with like 360-degree movement. But later on, having studied his character more in depth, we realized that his arm goes only up to 160. So there was a limitation here. So the takeaway was just to make sure when working with IPs, make a point to study character in terms of behavior and constraints, because they already have personality developed running up the show, so people know how they're going to act. So this is the Walter. You can see his arm movements like pretty much under, like not all in circle. And since we had been provided with high poly TV show models, which were pretty awesome, but we had to remodel everything to turn them into game-ready assets. For hard surface models, we used Simplygon to just reduce the poly count and manually remodel all the characters. Images on left are high poly models, which are around 10,000 polygons, and on the right are the low poly versions, which we recreated. The other challenge was that we had a list of backgrounds, props, other elements which client wanted us to use, but all of them had to be converted into game-ready assets. So we decided to use combination of 2D and 3D assets to improve overall app performance and still without compromising on high-quality show graphics. So here in Yellow Submarine scene, we're using flat 2D background with linear animation. So Submarine is not moving at all, it's just the background moving like linear transition. And the blue light rays you can see, it's also a 2D asset with a pivot point off the screen at the top, and just the rotation animation is going on. We have used Maya for most of the character animation, which require efforts for animator. But for hard surface models, we decided to create mechanical animations in Unity to give developers full control to tweak and edit animations where needed. For example, here, we added pivot points in Maya. We imported the FBX file into Unity and created a simple mechanical crane animation within that environment. So the crane animation was to be synced with the character standing beneath it, like if you can see those two ants. To achieve this, animating the crane in Unity gave developers full control to time and sync both animations. While using a combination of 2D and 3D assets solve the performance issues, we were confronted with a new one, like this one. For scene lighting, we had to rely on image adjustments since source light would impact models but not have the same effect on flat images, like the background is 2D and the model is 3D in the front. Hence, we decided to play around with the image saturation and materials to create a color tone we were aiming for. In this image, we have changed this image saturation and darkness to match the overall scene lighting. So if you tap on the moon, sun will come down, so you have to change all the colors. So it's just the saturation material tweaks. We were trying to create the illusion of underwater scene with the help of particle systems. There are several types of water bubbles in the scene with different properties. I used two types of particles to create this sort of effect for the turbine in the back. But sometimes using too many real-time particle systems can affect the game performance. Here we have used 2D images for light rather than light like particle system. But the challenge was that lights are interactive. User can tap on them. To give it particle effect feel, we achieved that by stretching and changing opacity of the images. And being an artist, I know like we have years of experience creating artwork, but when it comes to integrating the artwork, usually developers or technical person will process all that to integrate the asset, which sometimes result in losing information. Then we started working in Unity, and quickly it became the center hub for game designers, artists, and developers to collaborate on one single platform and integrate what they are creating. This gave artists like us full freedom to explore and create content, import directly into the project without anyone's help. So now hand over to Hamid, who has joined us remotely from Skype back home. So Hamid, over to you now.
Thank you, Hira.
Yes.
Hi, everyone. I hope everyone's doing great. My name is Hamid Ali, and I am a senior games developer at Tintash. I worked on Beatbox as a lead developer and been a part of this amazing journey from R&D phase to the launch of the app on multiple stores. So back in 2016, when we started working on Beatbox, our aim was to use something that would help reduce the overall development time so that the team can focus more on art and design. So we were looking for something that would allow us to rapidly prototype by setting up different environment designs for each song and then select the one that suits our needs. Secondly, we wanted to get as close as possible to the TV series in terms of look and speed, and we were looking for something that would high quality visual effects. As feedback is most about visual, so we definitely wanted to use a tool that is not much challenging to learn for the artist. So we can work on things like particle effects, and we wanted something that has a strong pipeline for importing 3D models and animation created in Maya, and then these animations can be used later in Unity after little to edit. And lastly, as we had explored multiple platforms, wanted anything that would help us deploy on that like Android, iOS, and Amazon without being in much app. So I guess these were, I believe, that's why we Unity for the development of that. So as we there a lot of animation, we worked a lot and character animation. Most of these animations exported as FPS and then used in Unity. Apart from that, we had some animations created in Unity and some objects were animated before. So we had a mix of 2D and 3D actors, each with individual animation, as well as team animation to serve characters, call to action performed by other characters. A big challenge was that most of the time several animations had to be loaded and played simultaneously, which resulted in a memory burst, and as switching mobile devices, it was a big issue for us. After a little example of how this of integrating animations evolved over time. So when we started working on the song, the yellow submarine design was really simple. All characters were sharing a similar logic for breaking. Animator override controller in Unity was very helpful in this case. We created a base animator controller, and all 5 main characters shared it by overriding the animation for each state. Without this functionality, we would have to create a separate animator controller for each character, and this would have resulted in a redundancy and a lot of effort for updating the flow. Further down the road, the design of the song increased in complexity. Characters no longer sharing the same animation flow or the state machines and had different behaviors. So we needed to create separate animator controller for each character, which defines the behavior of just that character. This had two advantages. A separate animator made the logic really simple and easy to comprehend. And secondly, only those animations were loaded in memory by default, which were part of that animator controller. To further simplify the logic and reduce memory load, we shifted to creating separate animator for each character for each scene. This resulted in a huge number of animator controllers but greatly reduced the number of animations which were loaded at the start of the scene. So this way we were able to greatly reduce the loading time of the songs. As we were desperately looking for enhanced visuals, but also wanted to provide a very smooth experience on mobile devices, we had to compromise between performance and visuals. As Hira mentioned earlier, that we had converted the very high poly models for TV series to low poly models used in mobile app, and that helped us achieve better performance, but we still wanted to enhance the visuals. So post-processing effect was a savior in this regard. It enabled us to apply realistic filters to scenes and fine-tune the visuals for dramatic and realistic effects. Also, Unity Profiler helped us debug the overall process in depth, like per frame basis, and optimize things out. So one thing I really liked about developing Beatbox in Unity was that a vast library of plugins was available, which helped reduce the overall development time. Uh, One small example is Text Mesh Pro, which was used in our scenes to display the lyrics. As we had to highlight the lyrics and sync them with the audio, functionalities in Text Mesh Pro, like getting an individual word or letter, made the implementation very quick. Apart from providing a lot of ready-made functionalities, Unity also provided us with the flexibility of writing custom plugins, like we did for audio recording for iOS and Android, and the integration was really easy. One such example is a custom plugin for calling and getting permissions at runtime in Android. So the whole plugin was written in Java, but integration was as simple as writing a line in Unity script to call the appropriate function from the Java library. So I think that's all from my side. Over to you, Hira.
Awesome. Thank you, Hamid. Let me just shift back. Okay. So a shout out to Parvesh and Usman, who were unable to join us today, but did an awesome job with concept and animations. And Tintash CEO Murad Akhtar, Manan and Joseph to believe in us and give us an opportunity to work on this project together as a team. And while Beatbox is made with Unity, we are made with pizza and tons of pizza. That's what we actually had. We also have a technical guy. We forgot to mention him earlier. Yeah, who helped us with, when we're stressed out with deadlines, and he keep us motivated. So he actually posted this picture. So that's pretty much it for today. And if you have any questions, feel free to ask, or you can always email us. Thank you very much.
Does anyone have any questions? We'll take them. Sure.
Hi. How did you go about trying to test your game on different devices in the market?
Wow, that's a very good question. So we were planning to release on iOS devices and Android in the same time span, and that was a colossal task in itself, because we had issues with the karaoke feature on the iOS devices alone, and we were not able to cater into Android. So we basically timed it out in a way that we focused on iOS first, and the functionality that worked fine on an iPad was not working fine on an iPhone. And we realized that that had something to do with the hardware itself and not it had, basically Unity was releasing the builds in a consistent manner, but when it got deployed onto the devices, we started having issues there. Plus we had some resolution issues as well, and a couple of materials were not translating as we had hoped. But we went into beta phase testing on iOS first and released on Android a month after, because we have more resolutions to cater to on Android side. And there weren't any bugs as such, but yeah, that was our process of going through it. We focused on iOS first, we went to Android next, and Amazon then was a breeze because, you know, testing on Android, we had basically covered all the resolutions. I hope that answers your question. Okay, thank you.
Did you have any special strategies for when you were negotiating with the IP holders about the lowering level of quality between the TV assets versus the game assets?
Well, of course, their preference is always to have the assets look exactly like the TV show. And that is what initially happened. When we showed them the low poly versions, they got really scared. And they were like, what is happening? This is not meant to happen. And we told them that this does happen because otherwise performance on mobile drops phenomenally fast. So what we did was we basically walked them through benchmarks that were out there in the market that helps them understand how these things are meant to look. Of course, you could always improve the quality, but given the volume of assets we required per scene, it was very hard to keep check of the poly count and not go over. So we tried to keep them very low, and we had at least 8 models in the scene at a time. Would you like to add something?
Yeah, so that's why we're using 2D and 3D combinations. So whenever we need to put like high poly, high definition assets, we usually export it from models. So it's a good combination to give like in the end, you export it as a high definition assets.
Yeah, so yeah, it was mainly a way of just walking them through the entire process as to why it looks more like this and less like their TV show, and they were fine with it because in the end they just wanted that app to get out and be accessible to the end user.
Thank you.
No problem.
You're welcome.
If anyone has any technical questions, please feel free to email Hamid. He'll be able to answer your questions.
All right.
None?
Thank you so much.
Thank you so much.